e square z Rn equal to n square a naught by z. Denominator z will be there. Okay, the expression for
Sir, there should be pi, sir, in denominator.
pi z will be there.
Yes, sir.
For velocity or this one? Pi will not be there, much check it.
No, sir, it will be there, sir.
Pi z n, no?
Yes, sir, pi z me square.
Expression for radius of nth Bohr orbit, pi m e square z m e square. One more pi will be there, no? Pi will be there, yeah.
Yes, sir.
Z square or z?
Sir, it's z only, sir.
Yeah, that. Okay then. Okay. I think no till here. Okay, fine. Like this, we'll also bring the expression for Vn. Vn is equal to z e square by 2 epsilon naught nh. And then expression for energy minus mz e square. Okay, sorry, z square e to power of 4 by 8 f naught square n square h. This is the nucleus at rest. Okay, these are valid. Now, when I go and check the Bohr's atomic model, I do see that in fact the nucleus is in fact also rotating. So I have to modify this atomic structure. So shall we say that Bohr predicted wrong? No, just we modify this atomic structure. So from the circles we'll draw it. Let this nucleus be here. And the electron will be here. So time being, I'll assume m1, this m2, and both will rotate about a common center, and that is the center of mass. Body C will be center of mass of system. Then after some time we see that okay, this will be the situation. They'll rotate about a common center with an angular velocity omega. You have come across this in rotation mechanics, SHM, gravitation, reduced mass idea. So let this distance be r1. Let this distance be r1. Let this distance be r2. Here I'll indicate r2 and r1. From the center of mass, all maximum will take help of center of mass. From the center of mass, m1 r1 equal to m2 r2, r1 plus r2 equal to r. The separation between the nucleus, this is the nucleus, this is a nucleus, and this is a revolving particle. After this expression for r1 will be m2r by m1 plus m2. Say Bohr were not knowing nucleus will be at rest, he assumed that, but later on from the experiments in the hydrogen spectrum they revealed that the nucleus is also revolving. So later on is follows what happened, they modify this atomic model. The same Bohr's postulate now. Now we'll see that one. The Bose postulates now the angular momentum of the system is constant of atomic system. So what he said, like there in the, if the nucleus at rest, what he said is like the angular momentum of revolving particle is constant here. He is telling angular momentum of system means IC omega should be equal to nh by 2 pi, not of revolving. Angular momentum of revolving system, all revolving nucleus as well as electrons, they are revolving. So what is IC? I think we have to go back to the moment of inertia. It will be m1 r1 square, m2 r2 square, m1 r1. You have this problem in SC Verma. Some 34th problem I feel. Two rods, particles attached. Find the moment of inertia of this about its center of mass. If you can remember that directly, you can write down the equation. Okay, let me simplify further. So this will be, I think m1 m2 will come outside, r square also, m1 m2 whole square. Here will be m1 plus m2. So finally will be m1 m2 by m1 m2 r square. What is that m1 m2 by m1 plus m2? We'll call that as reduced mass. How you define 1 by mu? Agree this? So this mu is called as reduced mass of the system. It's not new. You have come across already here in the SHM everything. So what is mu? Mu, I'll give specific name. That value of IC we are going to substitute here. There's a primary equation 1, 2. Substituting that, IC mu r square omega equal to nh by 2 pi. Who will provide required centripetal force? Will provide required centripetal force. So this will be equation number 3. The electrostatic attractive force between them. Let me write only F. What shall I write? F is equal to m1 omega square. Shall I write r, r1 or r2? The electrostatic attractive force between the revolving particle and the nucleus will provide required centripetal force. So what shall I write here? R, R1 or R2? R2, no, the distance of electron from the center of mass. You should not write R, you'll go wrong. Oh, symbols. M1, R1. Yeah, nothing. Okay, this will be R1. Is it okay this? Here maximum of you go wrong. The particle is rotating about the center, that's all, not about the nucleus. So what is the distance from the its path, its circular path to the center of circular path? That is R1. That should be substituted. So let's substitute the value of R1. This F should be equal to ZE square. This should be R square here again, equal to m1 omega square. What is R1? m2 r by m1 plus m2. Next, one more step. What is omega square? I change symbol, nothing. M1 R1 square plus M2 R2 square, okay? Just here the symbol was there. Change it. This is R1, this is R2, no? Okay, now omega square has to be replaced. This is equation 4. Put 3 in 4. This everything shall I write mu r omega square nh 2 pi mu r square whole square. Mu r n square h square 4 pi square mu square r to power of 4. Okay, now we got expression for r. 1 r square get cancels, 1 r also, r will be there, 1 mu also get cancelled, n square h square 4 pi get cancels, so n square h square epsilon naught. Okay, till here no problem. Z e square, 1 pi will be there, pi z e square. Then mu. Okay, see all of you, once carefully analyze, check it, I may write or if you say yes, then I'll proceed further. This is the expression for the radius of nth Bohr orbit. But since we know in terms of Rn, I wanted to express in terms of A naught. I should bring expression for A naught here. So therefore I'll slightly modify it. R equal to n square h square epsilon naught pi e square z me, so that I can bring that Rn, that A naught, all the symbols. So here will, let me divide and multiply this equation by me, mass of electron. And then what is that? H square epsilon naught pi e square me. This everything will become A naught. This is the expression for radius of nth Bohr orbit if nucleus is revolving. I think you have to remember this formula is very, very, very important. Sir, if mass of revolving particle is something different, what you are going to do? I'll calculate mu, that's all. If mass of revolving particle is some 100 times or 200 times more than that of electron, let it be, no problem. That everything will be taken care in the mu. If the z equal to 3 or something, let it be. If charge of electron instead of minus, if it is some other charge, that you have to take care here. I think that will be taken care in the z only here. Z e square will bring it, no? That has to be taken care in the z. Okay, now this is about the, if the revolving particle is having some mass appreciable to, comparable to that of nucleus, will bring it here. Similarly, I want expression for energy also. Yeah, what is the total energy? Total energy should be sum of potential plus kinetic. Again, derive expression. The expression for energy will be En is equal to what is the total energy? Will be in the form of potential plus kinetic. What is the kinetic energy you are going to write? Half I omega square. Half I see omega square by 2, not mv square like that. In books, the derivation is there. Just see once. I think if better remember this formula. Make observation. We'll have two problems we'll discuss. I think one is sufficient. May not be. One problem we'll have. They'll both revolve